Okay, so we'll start. Just today, we'll take 20 minutes together to give you some insights about LHYFE. So we are talking about hydrogen, green hydrogen production. So first, we'll start with a small presentation of LHYFE, what we do, and what is our offshore roadmap. We talk more specifically about LHYFE, so a demonstrator which happened a 1 megawatt production unit, which was placed in Le Croisic, not far from here, last year. And also about the nearshore future, about the next project called HOPE. It's a 10 megawatt unit, which we'll discuss that today. To start, just a very brief introduction about LHYFE. So it's a quite a recent company, founded in 2017. It's a French company based in Nantes. Our headquarters is in Nantes, and we are about 200 people, spread in 10 countries. So most of us are in France. And then also Germany, where we have a big team there in Cologne mostly. So what do we do at LHYFE? In fact, we follow hydrogen projects from development to delivery. So we are involved in development phase. We are, of course, in the design and construction. And then we operate our plants, and we deliver hydrogen to clients. So we are quite integrated from this very development towards delivery. In terms of production sites, so we are an operator, we operate our plants. We have our older site, which is in Boin, operated in 2021, not far from here. It's a 1 megawatt site, but then we are, as you can see, many are being constructed and being built currently. So 2 others in France, one in Morbihan, Buléon, and other one in Occitanie near Bessières. They are producing already. It's a very last stage of commissioning stage today. And then Germany, where we have a huge potential in Germany for hydrogen production. And this is our onshore site, so coming about 10 megawatt units. But on top of that, we are looking at offshore production, of course. And for that, we have this LHYFE project, which happened last year, where we were the first in the world to produce hydrogen offshore directly connected to a wind turbine. And just to give you a bit the roadmap of course, at LHYFE we produce hydrogen onshore because it is easier and it's already a bit of a challenge. It's a new technology. However, there is really this will and willingness to look at the offshore part. Why offshore? Because you need space for hydrogen production, you need water, and you need also renewable energy. These 3 factors are available offshore, and we are talking about large-scale production. You need to look at it offshore. This is really a will, and we are a strong believer that will be the future of hydrogen production will happen offshore. This is why LHYFE has developed a roadmap for that, because of course, before doing large-scale, hundreds of megawatts of production offshore, we need to go step by step. And the first step happened already last year. It was a 1 megawatt electrolyzer unit on a floating platform, which was connected directly to wind turbine, not from here in Le Croisic. The next step is for 2026. It's a HOPE project. It's a high-scale demonstrator. It's a 10 megawatt unit in Belgium, near Austin, near shore from Austin. We see that a bit in detail later on. And then, of course, the large scale that we foresee is the massive production of hydrogen. We're talking about hundreds of megawatts of electrolyzer on centralized solution, as you can see here, or decentralized solution on single wind turbine. One brief presentation about the project LHYFE. So it was a H2 unit, 1 megawatt electrolyzer supplied by a partner, Plug Power. All the units was condensed in a small floating unit supplied by Jeffs Techno, who was the partner of the project as well. Of course, the site located, it is within open sea near site, where we are able to be connected directly to this wind turbine. And then this is a grid connection that you can see towards the onshore grid as well. And so from that on, since 2022, the unit was first at quay in Saint-Nazaire, where it was fully commissioned and already being able to produce at quayside. And then last year, for 5 months, we were able to actually produce hydrogen offshore. In a fully unmanned configuration, that is to say that nobody was there, so it was fully operated onshore by a remote center. And of course, we were only going there when we had, let's say, maintenance to perform curative maintenance. but it was the very also first one to be fully unmanned configuration. To give a bit more specific of what looked like this unit, this is this floating unit where we had some different containment. One of the main one is water purification, so you need to purify the water. Seawater, of course, it's possible, but you need to make it purify. Then you need to go to the electrolyzer system. Then, of course, you have all the power supply, power transformers to ensure the power for this electrolyzer. And then you have the actual production of hydrogen. However, you may see something that what is here, it is a H2 vent. That is to say that the produced hydrogen, we were not able to have an export pipeline 25 kilometers to the shore for a small unit, so we had to vent it. So it was ready to just to demonstrate that yes, it's possible to do it. However, we cannot make any value of it. It was just to demonstrator. This is where we, of course, want to go to the next scale to make value of this hydrogen produced offshore. This is where come these HOPE projects. So HOPE is the name of a consortium. LHYFE is the leader of this consortium, and we are in charge on the overall design, construction, and operation of the project. We have Plug Power as a partner with supplying the 10 megawatt electrolyzer unit. We have Alpha Laval providing the water treatment package. And then we have this export pipeline supplied by Strom as well, who is making a specific technical qualification to qualify his pipeline for hydrogen uses. It was former an oil and gas supplier, and now it's specifically for hydrogen. And of course, we are also working with the POM. It's a local partner, a bit the counterpart from ECN or OpenSea, but they are based in Austin. They have this test site able to take a demonstrator on their site, and this is near Austin. Just to say that in terms of funding, so of course we have support from Europe and from Belgian state as well, and we have more than 20 million support to make this project happen. To be a bit more specific at what this project looks like, so this is a top view of Austin Port, the port of Austin here. This is an existing platform, as I said, it is today where it is meant to accommodate some testing and small demonstrators. And this is where, so it's very near shore. It's only 1 kilometer from the shoreline where we plan to have this unit. It will be on a jack-up system. So it's a matter also of saving cost because we will take an existing one, make it retrofit to adapt it for our needs, and deploy it on the jacking system there permanently. And then we will be able to have offshore all the water treatment. So you take the water from the seawater, you purify it again, you produce the hydrogen offshore. We purify the gas of hydrogen offshore as well. And then we have an export pipeline going to an onshore site here within the port of Austin, where we are able to compress it to higher pressure. We compress the gas and to have lodges to be able to distribute the gas into trailers and to different various of off-takers and users afterward. One small thing you can say, what about the electrical supply? Because of course we need electricity to make this production of hydrogen. And unfortunately, it's not the case that Sea-Life, for instance, we don't have any wind turbine available next to it. So we are taking a cable from the onshore grid, making a subsea cable to connect, to supply the power, and then we export the hydrogen. So of course, the purpose is to demonstrate that yes, it is actually possible to do this production again happening offshore at a large scale, 10 megawatt, which is a big scale for hydrogen today, if you look at the stakeholders. And just to be a bit more specific on what we do, and this is just an illustration of what is the onshore site. So onshore, we will have some compressors here to go up to 380 bar to compress the gas because it is produced at 40 bar. We go to 380. And then you have lodges where you have the trucks coming and to be able to get this hydrogen filled up. So in fact, we don't have any fixed storage. It is mobile storage, so tube trailers. That means that you will have 2 or 3 trucks per day coming, getting filled, and being able to deliver customers around the vicinity of Austin or whoever customers needs hydrogen. Just to also give an illustration of what kind of engineering and safety assessment, because of course safety is a major parameter, and also because hydrogen, there is a risk relating to hydrogen. So of course it's being looked very carefully by the regulation, by the stakeholders. And you can see here an illustration of all the safety assessment and the quantitative risk analysis you need to perform for the various events. What if I have a small leakage? What if I have a bigger leakage? To see the probability of impact effects that you may have. So this is typically something that we are doing, of course, as part of our own standard, but as part of the regulation as well. And also just to give an overview of what is happening offshore. So this is the top view of the layout, where basically you have three main packages. First one is electrical packages. So you have a subsea cable coming, being connected to this. It's a 36 kV cable, HVAC. We need to convert it to lower voltage and then to HVDC. So you need a direct current to make electrolysis happening. In parallel to that, you have the water package. This is where we purify the water. So we have seawater at the end. We need very purified water to do the electricity system. And then you have here the main electrolyzer package to produce the hydrogen, to purify it. And then you have the export pipeline going back to the shore for actual compression and then distribution. Just to give you a bit of more technical parameters, so it's very near shore. It's only about 10-meter water depth. So it's kind of easy condition, I will say, compared to, for instance, LHYFE, where it was a floating unit exposed to Atlantic Sea. Here it's more sheltered area within Austin. And in terms of dimension, it's a jacking system of about 35 meters by 20 meter height. So it's typically, you can see to compare the size against an existing structure which is already happening here and what we have here today. Yeah. Just to give a bit of insight of what is actually happening in the project, of course, we have some technical and permitting drivers to consider, of course. We mentioned that, of course, the safety aspect is one of them, but not only. There is also the environmental aspect. So here, locally, you have some Natura 2000 area classified. Here you have the port development, which will extend potentially its area around here. We have a site heritage as well here, so of course we have to deal with that and to cope with that. This is why we had to define a routing for a subsea cable and for our export pipeline between this one. And this is why we are considering to have an HDD, so an horizontal directional drilling, so drilling directly here, going out over here, and to connect it to the barge. So this is, I will say, a typical configuration that you may see for grid connection, for wind farm, for instance. Of course, when you have this beach and dunes, which are protected area, you need to go under it, basically. However, the new thing is that we will have this as well for a pipeline full of hydrogen. So this is well, of course, where you have to go to more specific consideration regarding our product. And just to give you, so this is what, of course, it's more standard 6 kV submarine cable pipeline that we have. And this is what is our pipeline for hydrogen. So it's not a carbon steel pipeline. It's called thermoplastic composite pipeline. So it's very light. This is one of the main advantages of this component. And it's qualified for very high pressure for oil and gas purposes since a long time ago by Strom. But for this one, it will only be at 40 bar and a 2.5 inches ID diameter. So it's quite small pipeline, in fact, not that big, because hydrogen is very light. And at 40 bar, you have enough pressure to be able to export it. So you do not need to have any compression offshore. You can directly export it here. And then this is only onshore that you do this higher compression system. Of course, it is easier and cheaper to do things onshore when you can, of course. Just to say as well that, of course, we'll have to be buried, to bury our pipeline, to bury our cable, of course, as you may see, to ensure that it will not affect the product integrity first and the safety of the stakeholders in the vicinity as well. Just to give a bit of timeline and the key milestones coming for this project. So this project has started in 2023, Q3 2023. In terms of engineering and feed engineering, today we are about 90% completed. What is happening right now, we are a bit busy with the permitting activities because, of course, when you talk about hydrogen, the regulation is not so defined today, so we have, of course, to work with the authorities for that. And there is 4 main, I would say, permit to get. One is a specific permitting for the H2 transport pipeline. To be able to transport hydrogen, you need a specific permit. The second one, of course, is the main one, is the environmental permit. So you need to make a full environmental impact assessment for that, as you will do for any typical offshore project, wind farm or whatever. You need a specific permit for the cable as well, and one permit for the onshore construction site, which is a more standard one because you have this small building being built as well. So this is what we are doing currently today, and about to see some of these permits were already supplied, and the others will come in the next weeks. Then we plan to have the first construction works coming in 2025, between Q3 2025 and Q1 2026, and the COD to have this site fully commissioned and be able to sell hydrogen to customers will be mid-2026. In terms of capacity, so you can produce up to 4 tons of hydrogen per day. And just to give you the equivalent of CO2 emission reduction, if you compare it to normal fossil fuels, it's about 22,000 tons per year. And of course, today, what we can share also today is that to make this project actually happen, one of the main drivers, of course, is to ensure that all stakeholders are happy to have such H2 production site unit offshore available within stakeholders, within public area. So the key points will really to ensure that the safety are well respected, to be able to convince and reassure people because it's the first one, the first kind of unit. Regulation is not yet defined. So this is really today what we can share in terms of challenges to ensure that all stakeholders are happy and confident that yes, we can move forward and make this kind of project actually happen. Thank you for your time, and if you have any questions, I'll be happy to discuss them. Mm-hmm.